Welcome to my deep dive session, GraphQL in Java world. Let's go for a dive. This is going to be 3-hour session, so thank you very much for coming here and actually joining this session. I know there's a lot of good talks happening right now, and it's going to happen as this talk goes on, so thank you very much for joining. Yeah, if this starts to work. Okay, first of all, let me introduce myself. My name is Vladimir Dejanović. This is my Twitter, my mail, my blog, my GitHub account, if you want to contact me online or follow me or whatever. I'm part of professional IT scene since 2006. In other words, I'm getting paid for the work I do since 2006, and over the years I worked on all kinds of projects, systems, like you name it, I did it. My day job at the moment is Senior Director of B2C Technology at PVH. PVH is a fashion tech company behind brands such as Tommy Hilfiger and Calvin Klein. My night job is founder and leader of Amsterdam Java user group. And beside this, I give talks at conferences, like this one, of course. And I'm Oracle Code 1 star and Java 1 Rockstar. But enough about me. So what this talk is going to be about. First, we're going to spend some time talking about GraphQL, what GraphQL is, what GraphQL isn't, things like that. But very fast, we're going to actually go to the deep dive part of this talk, and everything is going to be happening in the code itself, because I believe that that's the best thing. Just show the code, look at the code, and see what happens. At the end, I will leave more than enough time for questions. So if you have any questions, please wait until the end, or you can always contact me online. I will be more than happy to answer any of them. Before I start, I just want to make sure that you understand this. All the things that I'm going to share with you come from my own personal experience. So take everything that I say as with a grain of salt. Basically, your use cases might be different than mine. So don't just go and directly do whatever I did now and put it in production, because majority of the code that I'm going to show is not production ready; it's demo ready. So it's just so that you can actually get a feel of certain things. Okay, so let's start with the obvious question: what is GraphQL? So I'm not sure about you, but whenever I don't know answer to some questions, I always do the same thing. I just go on the internet and start searching, right? And this was the same thing with GraphQL. So I heard about GraphQL. I was, okay, what it is? I searched, and I found the official website, and on the official website, there was official definition. And this is official definition. GraphQL is a query language for APIs. So when I read this, I was like, okay, but what does it even mean? So then I continued reading more and more and more, and I came to a very simple conclusion, to the answer of what the GraphQL is. GraphQL is a specification, nothing more and nothing less. It originated from the Facebook, because in the Facebook, when they were building some APIs, they encountered some problems, and basically GraphQL was their solution to those problems. But then they also thought, okay, you know what? Probably some people outside the Facebook face similar issues, so let's just open source it. And basically, GraphQL was open source as specification in 2015, and since then it was implemented in many languages. So you have, of course, implementation in Java, the one that I'm going to show you the code in. You have, of course, JavaScript. You have in Go. You have in PHP. You have in Elixir. You have in all kinds of languages. What's very important to remember, why I actually have this slide, is that you remember that GraphQL is a specification, nothing more and nothing less. It also means that we, as developers, we're not going to use specification. We are going to use some implementation of a specification. And implementations can differ in different languages, even in the same languages. Some of them may cover the whole GraphQL specification. Some of them could just do the parts of it. In some places where the specification is maybe unclear, people who actually implement the specification can decide, okay, let's go left or right. They can also add certain things which are not part of the specification, so we need to keep that in mind. And to know, okay, which kind of implementation we're using, and what's the limitations, and what actually it adds, and it shouldn't be maybe adding if we go pure GraphQL way. Because if you just change the implementation, your code might stop working. When we talk about GraphQL, GraphQL consists of two big parts. So the first part is schema definition language. And again, I assume that majority of us here basically build REST APIs, right? Everybody built REST API? Anybody awake? Okay, nobody's either awake or nobody built REST APIs. Okay, so either way, when we build REST APIs, we usually have some specification to define, okay, how our endpoints look like, things like that, payload, things like that. So either Swagger or an open API spec or API blueprint or something else. So I worked in all kinds of specifications and schema definition languages, and from my experience, GraphQL is the most powerful one. You can, in a very easy way, basically express certain things that in other specifications you can't, or it's very difficult to actually express. The other big part of GraphQL is basically the query language. So as you probably know, in REST, we just send a request, basically, and we basically get a response, right? And it's usually, okay, like we hit the URL, we send some arguments, we send some parameters, things like that. Well, in the case of GraphQL, we basically send the whole query language, where actually, again, give us a lot of power to do some really crazy stuff, and we'll see that in the code. So one thing to remember is that in case of GraphQL, schema is mandatory. And again, if you come back from the REST API world, you probably know, okay, schema is an optional, at least in REST. Well, in case of GraphQL, it's a mandatory thing. And the reason why it's mandatory is very simple. So on the initial connection, basically, we have a client and a GraphQL API. When the client connects to the server will send back, basically whole specification and say, okay, you see, this is my specification. This is how your request should look like. This is how my responses will look like. Then the client should actually store that somewhere in its own cache, so to say, and check any kind of request before it even sends to the server. Because why would you send a request if you know a front end that it's not valid one, right? Even if you're a naughty person and you actually force the client to send invalid request, what's going to happen is basically the server is going to take the request, validate it according to the schema first, and then if it's not valid, it's going to send error right away. So it will not do any kind of work processing, chasing basically resources, things like that. Nothing. Nothing will happen. It will just take the request, validate it. If it's not good, just send it back. This comes by default with all implementations that I actually saw, and this should be like the thing that actually should be everywhere. And again, this allows us as developers that actually we can stop thinking about certain things, because again, we can think, okay, like if the request came, it means it's already valid. So we should just think about the business logic to actually implement, that request. Okay, so let's now go to the code. So basically, we are going to actually here build like a demo conference application. It's a very simple app, but again, it's something that I think should everybody understand, hopefully. So like every conference, we can't have a conference without attendees, right? Because if there is no attendees, like what's the point of a conference? Also, we need a speaker, right? Because somebody needs to give the talks. If there is no speakers, then what you're going to do in the conference. And of course, we need the talks, the thing that actually connect the speakers and attendees. So basically, this is our, let's just say, database layer. This is basically what we're going to have. What I'm going to use is a GraphQL Java. That's basically implementation of a GraphQL in a Java language. I'm going to use this, but I'm also going to use something else. And this is also GraphQL Java Kickstarter. Reason for this is very simple. GraphQL Java, you can think of it as a core engine basically for building the GraphQL APIs. It actually has all the business logics, all the implementations, everything that you actually need to understand the GraphQL Java. However, because you can actually expose that engine in multiple ways, they said, okay, you know what, we don't want to take basically, decision, okay, you have to do it in this way. We will provide you with all the tools that you actually need, so you can actually plug and play that in your whatever infrastructure you have in architecture and just go nuts with it. Of course, sometimes it's more difficult for some people than to actually just start with the GraphQL. So that's why the group of people says, okay, you know what, we are going to actually build a Kickstarters, where it's very simple ways that you can actually connect the GraphQL Java engine with some most common ways to actually have interaction. Both approaches basically have pros and cons. We'll see. Like I always say, talking is boring, so let's look at the code. By the way, all the code is already online on this URL. So basically, here's whole code. All basically the steps is in different directories. There's even a README file that actually it's kind of going to show you, okay, go from this to this to this to this, so you can kind of follow along. Okay. So first, let's see basically what we have. So at the moment, we have only init applications, so we don't have really almost anything. And if we look here, basically you will see that we have some simple Spring Boot application. And that's it. For now, let's ignore this, because we don't care about this thing here. Then we have, of course, POJOs. Or actually, let me go show you first the POM. So in a POM, basically, we have like web starter, right, from the Spring. Then we have like JPI. We have some dev tools just to make it easier, and we basically use as a database H2. And we use Lombok because I'm a lazy person. So if we open an attendee, for example, basically we just see, OK, that's an entity class with the data, of course. So with this, basically we say, OK, this is our table. This is annotation from Lombok. If you don't know about Lombok, basically this says, OK, like generate all the getters and setters for me so that I don't have to do it. And basically here we have like two fields, basically, ID of a type long and the name of a type string, right? So that's for the attendees. If you go for a speaker, again, speaker is a very similar thing. We have entity, right? Again, data, again, because we are lazy. We have an ID of a type long, name, and Twitter, because, you know, speakers have Twitter accounts so that people can follow them. Also we have like talk, and talk is very similar to everything that we showed so far. We have an entity, data, again, like because we are lazy, ID of a type long, title, and description. So it's very simple things, right? This is the basically just a database layer. Of course, we can't do anything only with POJOs themselves. We need repository. So if you go to attendee repository, we will see that basically, again, Spring Boot did almost all work for us. Again, because I'm a lazy person, I don't like to type a lot. So I just said at repository, and attendee repository extends simple JPI repository of a type attendee, and ID is of type long. Similarly, we have a speaker. Again, the same story. Again, repository, speaker repository extends JPI repository for a type speaker of ID type long. And the same thing with the talk repository, so exactly the same thing. Then because I want to actually make my code look a little bit nicer, I also have services. And basically here, like actually standard Spring services. So I just say, OK, service and auto-wire some things that basically depends that I need. And here I created some basically methods that I'm going to use later in the code. So like find all attendees for the talk, things like that. Similar with the speaker and with the talk service. So what basically we need to do when we want to actually do with the GraphQL is, again, there's two approaches that we can go. So like I said, schema is mandatory, but you can do schema first, then write the code to wire it to the schema, or you can go code first, add annotations, and basically from that generate the schema. So there's like the first choice that you need to make. I personally like to go with the schema first approach, and I'll demo also later why. So if we go with the schema first approach, well, what we need to say? Well, first we need to define the types that actually we're dealing here. So I have type attendee, and what my type attendee is going to have? Well, let's just copy what we basically have here. So let's just do, oops, not this. So basically, let's just copy this, copy paste for the win, right? We go back to the GraphQL schema. By the way, is this big enough for everybody? Again, if I go too fast or something you don't see, just all good? OK. So we can just copy here. And of course, this is going to complain because we can't have this. So we can say ID is going to be of a type ID. And we're going to put exclamation mark. So let me just finish this, and I'll come back to then later. Then the second field is the name, right? And it's going to be of a type string. If I know how to type. So basically here I'm saying, OK, I have a type, and its type consists of certain fields, and these certain fields are certain types. So we get some scalar types by default. We have an ID, we have a string, we have int, we have float, and we have Boolean. So basically, these are all the scalar types by default which we get in GraphQL. I think that we don't need to go and basically explain what is what. The only one which is kind of strange is this one here, which is ID. Actually, what this type says here is, OK, treat this as a string. However, this isn't for human people. Basically, it's not like it shouldn't be humanly readable. So it's basically to cover all the possibilities of the ID. So it doesn't have to be always the number. It can be like a combination of some crazy stuff. But again, this should be basically ID. So it just treat it as ID and don't worry whatever goes inside. This thing here actually means this field is mandatory. So basically, if I have type ID, the name, in this case, is an optional thing. I can have it, but I don't have to have it. But when it comes with ID, it has to be present at all times. So it can't be, it can't be null. Okay, so let's then define the next type. The next type is speaker, right? Speaker. Okay. So again, we can just go to the speaker and just again do the copy paste because it's easier. Okay. So again, we have ID of a type ID. Again, let's make it mandatory. So let me delete this one. Then we have name. It's string. Then we have Twitter. It's also string, right? So we can delete this thing. And then let's also add the type. Type talk. I don't know what's wrong with me, but I'm not really typing good. Okay, so type talk. Again, we have an ID, title description, right? So we can just go here. ID. Okay, title. We just put string, right? And we have description. Again, we put string, right? So that's it. So we have down defined all the types. Again, you can also define the scalar types if you want. So you don't have to use only the ones which actually come with GraphQL by default. So you can just say scalar and basically date. And basically in this way you will define the new scalar type that you can use. The only thing that you need to remember is that whatever you actually define here, the backend system needs to be able to understand. So if I put here something like, great, from the GraphQL point of view, it will be great, but my backend system will not know what to do with this. Now, when we define all the types, we're actually coming to the heart of the GraphQL, where we actually say schema. And then basically here, we need to define something. So let me just see if yeah, so basically here we come to the query language of a GraphQL. And the query language consists of 3 parts. The first part is basically query or read only. So we defined it in a very simple way. We just here schema, query of a type query. And now, basically we define query like any other type. So it's not anything special here. Again, I can use here whatever I want as a name, as long as basically I wire it correctly to the code in the backend. However, keeping the same names, like query and things like that, keeps it consistent so that anybody who opens this schema will know exactly what this does. So let's say all talks, and it's going to return array of talk. So this is how we define the array. So basically here I'm saying, okay, like in the schema, the heart basically of a GraphQL where the user can interact, there is going to be a query. The query is going to type query is going to consist of all talks, which is going to return type of talk. Also, one thing that you need to remember about the query, because it's read-only, it's the query, the implementations of a GraphQL language usually do optimization, say, okay, if it's querying, okay, it's read-only, so we can basically do that in parallel to basically gain the speed and everything. So make sure that never change the data in a query, because if you change the data in a query, you're going to get some really funny results. And people will want to hurt you afterwards. Okay, so now, basically, we have a schema part, but now we need to basically connect it to the code part. So let's look again in the POM again. And basically here, you will see that we have like a GraphQL part. So basically, this is the implementation part. So first thing first, I have, of course, a GraphQL Java implementation, because if I don't have that, nothing will work. Then what I also have is basically something like called GraphQL Java Tools and GraphQL Java Servlet. At the moment, the versions which I'm using are still part of GraphQL Java. However, they actually moved to the completely different repository called GraphQL Java Kickstarters. I just didn't bother to actually update my code. So basically, here are some helpers classes that we are actually going to use to speed up the process of actually developing the code. So if we go back to our Spring Boot application, we will find some code here which is basically commented. So let's uncomment that one. And let's see how it goes, how we continue from there. So the first thing first, basically we're defining here a bean. And again, this is not really any magical code. This is a very standard way how we defined basically the servlet bean. in case of a Spring Boot application. And in this case, we're mapping it on a /GraphQL endpoint. So whatever request comes to the /GraphQL endpoint, it will go to the servlet. And here we use simple GraphQL servlet, new builder, and we say build schema, and we say build. And that's it. So basically here is, again, one of the classes that actually come as helper classes from a Kickstarter. So we don't have to do all the crazy stuff. We just need to do one very small thing, which is called build schema, right? So let's look at the build schema now. Well, build schema is already here. So we say schema parser, new parser, and then we provide with the file actually that I was writing all along, right? So basically we say here, okay, here is basically the file which contains the GraphQL schema, and just parse it. Basically, when it parses it, then actually we have something called resolvers. We'll come back to this later. We say build, making executable schema, and that's it. So let's see. Will this compile? I hope that actually I'm in the right directory. Okay, so it's not going to compile because what is special was a project? Huh? Oh, I'm in the wrong directory. Okay, I'm in the wrong directory, yes. So you see, like, this is what about directories that I was actually talking about. So we're at the moment in it. Actually, from there, I'm building on. So let's just build. So now we're in a good directory. So hopefully now it builds. So will it compile? I think yes, because it's a demo, right? Usually demos should work. Okay, so it compiled. Let's see if it's going to start. So now is the moment of truth, right? To see how my live coding skills are. I suspect that it's actually... Will it start? Will it start? No, it crashed. So I know why it crashed. And the reason why it crashed is very simple. So basically what my helper class is going to do is actually here, when I say, okay, parse the schema, I'm going to say, okay, I'm going to parse the schema. So I'm going to look at the schema here. And basically, okay, you have type attendee. Okay, so you have a class attendee, which is exactly the same name. So I'm going to map those two, right? Then basically I have a speaker. Okay, the speaker, again, we have a class speaker. Talk, okay, and we're going to with the talk, right? Then we come to the query, and it says, yeah, I don't know what this is. So basically here's like, okay, like, I don't know what it is. So let's build this class. So let's just say copy, and let's actually here create new package. Let's call it resolver. And now let's just add the class, Java class. It's going to be called query. Oops. And again, I'm using exactly the same name, so that basically, the GraphQL Java can actually, very easily map one-to-one. Also, I need to implement GraphQL query resolver. Again, with this one, I'm saying to my GraphQL Kickstarter, okay, this is the class which is actually going to resolve queries. So the next thing that actually I need to do is I need to basically go here and say, okay, what I have here, I have all talks. So I basically somehow need to resolve this. So again, I'm going back to here to query. I'm going to copy paste. I say public. Well, arrays list, right? We say talk. We say all talks. We don't get any arguments. So all talks, there is no arguments. Okay, so let's first import this. Okay, let's import list. Import list, cool, import list. So what I actually need here is I need to somehow return, right? To return all talks. Well, how can I do this? Well, I can do this very simply in this way. So I can say private final talk service, yes, talk service, yes, and then I can say here required args constructor from Lombok, which is actually going to create a constructor which actually takes all the final classes automatically for me. And then I say here, okay, talk service, find all. That's it. It should work, right? Well, not yet. Because we still need to actually do one more thing, and that is actually to use this part here. So here, basically, with these resolvers, we actually are adding all the resolvers. We're helping, basically, GraphQL Java to map our schema to our code. So here, I just need to say new query, and we are going to provide, I'm actually, I forgot to actually add this one here, so I need to here have speaker service, yes, speaker service, then we have attendee service, because we're going to need them later, then we have here talk service, talk service, right? Okay, so basically that's okay, then we have here talk service, we also need to import this method, right? Yes, mine query. Then we also need to basically change this one here. So it needs speaker service, attendee service, and talk service, right? Okay, so now, if I didn't do any mistakes, everything should be good. So let's compile the code again. And now it should work once it's compiled. So as you can see, like so far, we didn't do anything really like that difficult. Basically, we just defined the simple schema, where actually we did the copy-paste almost of everything that we actually already had. We basically defined one more new class, which is called query in the resolvers. Basically, we say, okay, implements GraphQL query resolver. We defined the method with exactly the same signature like the one we had in the schema. And basically here in the resolver, we just added it. That's it. So let's see if this one, okay, so this started. So one more thing that actually I forgot to show you in the POM file is I'm using one more helper class, and you can see it has something very important here, dev only. So basically, with this thing here, I'm creating, actually I'm adding like one file, some JavaScript and some XML to get like, like dev environment to play with the GraphQL. But keep in mind, never push this in production. So this part should be removed when you go to production. So if I just go on localhost 8080 and so go GraphQL. Okay, so basically I get here, I get this. Let me just make this bigger. So this one here is a simple client for GraphQL. So here I can say now query, and I can say all talks, and I can say, so talks had ID, right? Title and description. And I can run it. Bigger, yes, of course. So big enough? Okay. And we say run, and basically here we get response. So a few things to notice here. First thing first, response is a pure JSON. What we send is not really a pure JSON. This is basically the GraphQL query language. So in pure JSON, basically we have like data, and in the data then basically we get a payload. The payload is basically exactly the same like we defined here. So we have all talks, ID, title, description. One more thing. Basically, as you saw, here I got like, autocomplete. So how I got this? Well, if you remember, basically what I said here is that, basically, yeah. So the server sent the schema to the client. So basically that's also what happened here. I have a client asks, basically connected to the server sent the whole schema, and then the client used that. So first of all, validate the requests, basically before it sends. Also, it allowed me to give like autocomplete, and it did another thing here, which is very nice, and that's like documentation out of the box. So basically here I say, okay, query, I have all talks, I can see, okay, talks consists of things that it consists here. So we'll come back to documentation also. So another thing that you can say here when you see this first time is, well, okay, this is just a crude REST API, right? So what's the big deal? That was also my first impression. But then if we just say, okay, let's say we don't want the description, right? We can just remove it. Then we don't get the description. So basically we can filter fields that we want out of the box. This is like the standard which comes with the GraphQL. Let's say I don't like all talks. I want to say this should be called talks. Well, I can just say do this, and basically run it. Now here it's talks. Again, I'm not sure about you, but I had like endless discussions with the people who are actually building the APIs and people consuming APIs about fighting about the names. Like one team wants this name, another team wants that name, the third team wants different name, and it's basically everybody wants their own name. So with the GraphQL, what we get by default is that if we don't want to call this title, we want to call this, I don't know, my title. Frontend can decide, okay, like I want to call this my title. No problem. Just go and call it. You're going to take basically talks, my title. So backend can actually call this however they want to call. Frontend can call it however they want to call, so it's no more fighting anymore, which is a very good thing. So we get like filtering out of the box, we get renaming out of the box, so we get documentation out of the box, and when we're on documentation, let's actually test that. So I can just go here and say, okay, title, so I can just add this. This is some doc, right? So, oops, so if I just now kill this one, rebuild, fingers crossed that it's going to work without compiling, you never know. So let's see, it should also now get basically with documentation. Okay, is it done? Yes, no, yes, no. Okay, so let's refresh. Also very important, always remember to refresh basically your client, because then you get the new schema. So if you go now to docs, title, and you basically see title, this is some doc. So the schema is also documentation. And again, because it's always, everything is validated according to the schema, you're never going to end up in a situation where your documentation or the schema is out of date. And like, I know that bites me more than once in real life. Like I'm reading the specification, documentation, then I ask the questions, and they told me, oh, it's like 1 year old. So with the GraphQL, it's never going to happen. Another thing, also that we should look into, which always basically comes with the problems, at least from my experience, is, okay, what do we do with errors? Because we say, okay, if everything is good, we get the data, it's here, right, in a data payload. But what happens if there is an error? So usually then we go, okay, like let's use this status code, let's use that status code, things like that, but let's just test it. So let's push something here which we know doesn't exist, and let's see what happens. Well, in this case, again, GraphQL as a specification has its own view how it should be done. So it says, okay, like if there is data, data will always be part of a data payload. If there is an error, we're always going to send it in as a part of an error payload. So basically here we get an error, and we get some error by default. Again, all of this is customizable. If you don't touch anything, this is the exact way that you got it. Okay, so let's now actually expand a little bit more on our GraphQL example, because at the moment it's very simple. So what I want to do is basically, okay, we have all talks, but let's say I want to also add all attendees, which is going to be an array of attendee, right? Attendee, then let's say all speakers, and let's return speakers. No, it's speaker. Yes. Yeah. You see, it's a problem when you don't know how to type. Is it okay? Yes, it's okay. So again, we do exactly the same thing like we did last time. We just do the copy-paste. Go to the query. You add it here. Again, we will need more stuff. If we figure out where my cursor is. Private. So we say private final speaker service. Speaker service, okay. Then we say private final attendee service. Attendee service, come on. Attendee service, yes. Then we say, okay, this one we're going to remove. Attendee, we say here public, right? List attendee, okay. Let's import. Then again, it's a very simple return. Attendee service, find all, yes. Then we also have here public list speaker, yeah, of course, speaker, yes, of course. And then we again do exactly the same thing like we did before. Speaker service, find all, and that's it, right? And we get, oh well, no, we also need to update this one here, because now it's like talk service. Oh, I need to now figure out what the, so it's like talk, speaker, and attendee. Is that right? Correct? Okay, I think that's the right order. Talk, speaker, attendee. Yeah, I think, yeah, return. Okay, cool, thanks. You see, this is like always good, because somebody's awake. And again, like I make a lot of mistakes. Okay, so hopefully now all of this will work, but let's add a little bit more, because I think this is like not that much interesting. So what I want to do is also add here something which is called speaker, and then speakers, because talk can have more than one speaker, and then let's return array of speaker. Okay, so what actually should we do with this one now here? Should we extend the Pojo talk, or should we do something else? Well, you can of course extend Pojo talk. The one thing that I actually didn't share with you right away, which is kind of also not nice, is again, like in the case of a query, it's very obvious what the GraphQL Java code does. So it actually says, okay, like I find the class, okay, I need all talks, I'll find the method all talks. With the Pojos, it did something different, because, for example, in the case of a talk, you say, okay, I have a talk, I found the entity Pojo talk, but then I see, okay, you want a title? I look, is there a field, basically public field available called title? Or is that a method called title? Or is that method called getTitle? Because we had the getters for everything, it worked. So in this case, if we run the code, it's going to say, I have no clue what to do with the speakers, because like talk doesn't have a field speakers, doesn't have a getter speakers, and and again, you can extend the talk, but there is a better way. So the better way is to create a new resolver, which is going to be called speaker resolver. Speaker resolver. Again, in the resolvers, right? Here we're going to say implements GraphQL. GraphQL resolver. And we're going to say here speaker. No, talk. I already made that mistake once. So what basically say we do here? So it's very important to understand this. So we have a query. It implements GraphQL query resolver, which says, okay, this is going to do all the queries for me. Whenever there is a query, look in this class, method should be there. In this case of speaker resolver, we have GraphQL resolver. And then we have this, basically we say type talk. So whenever you find some field on the type talk that you can't resolve itself, then basically I will tell you how to do it. So basically, again, we're going to do the same thing like we did last time. Just do the copy paste. So basically copy this field. Actually, this should be called talk resolver. Refactor, name. See, I always make mistakes. Talk resolver. So it's talk resolver. Basically, push this one here. Public list speaker. Okay. Let's import this. Of course, we need to import the list. Well, in this case, now we need to have an argument. And the argument is actually going to be talk, because we have an object talk, and we need to resolve some field on it, but we don't know. So basically, we're going to just take that object, find this method, and just say, here it is, resolve it for me. So then here we have we need private final speaker service. Speaker service. Required args constructor, yes, this is the one. Basically, we say return with speaker service, find all talks for talk. Put it here. Then again, we need to add it as a resolver. So we just add here a new resolver. New talk resolver, yes, and we have a speaker service, right? And that's it. So let's now build the code, just for sure, and let's see if it's going to work. Who thinks it's going to work out of the box? Anybody? Okay, so I have like one. That's good. That's a sympathy vote, right? Well, again, it should work because this is demo, right? So let's run it. And let's see how it goes. I think it should work because I did this demo more than once, and like it worked every time so far. So hopefully, like my streak goes on. But again, as you saw, we didn't do anything really special. Basically, we just went to the schema. We added in a title, basically in talk, new field speaker. We added new resolver, which is called GraphQL resolver for a type talk. We added the method with exactly the same signature. It takes as an argument talk, returns the list of speakers, and basically here we added new resolver, and that's it. Okay, so this is running. So again, let's refresh the browser because we need to get the new schema. So basically, let's remove this. So we say query, right? All talks, and we say now title, right? And we can say speakers now also. And because we get the whole object, we can ask whatever we want from a speaker. So let's say name and Twitter, right? For why not? And it works, see? Demos always work. In production, not always. And again, we can do exactly the same thing like we did before. So if you don't want to call these speakers, you can call this like my speakers, or we can call this talk speakers. Speakers. We can just rename it. So we can do whatever we want to do. We can go even a step further. Oops. We can say if, no, include if true. And then we say, of course, nothing changed, right? But if we say false, then this one doesn't exist anymore. So we have actually basically the more powerful things that say, okay, I want this part, I don't want this part. Again, like if we need to change this value here, it's not really that different from actually removing it or adding it, right? So we can actually, what we can do is we can say, here my call, let's say, and then we say with speaker, and then here we can actually say, oops, okay, with speaker. Okay, am I doing it right or not? Oh yeah, I forgot the type. Boolean, so basically it needs to be Boolean. And this, yeah, with speaker. Oh yeah, it needs to be mandatory also. Yes, now it's cool, see? I don't use this often, so additional thing we can actually here, we have another part. So I didn't show you actually the network call. I will show you network call after this. But whenever we send a request basically to the client, we send two things. We send a query and we send variables. So variables basically we can just say with speaker and then I can say here true and I run it and I get speakers, or I can say, okay, I just want to change here it's a false and now I don't have a speaker. So if I open basically network call to actually show you this, so let's just refresh this. Okay, let's also make this one bigger. So let's remove all of this. And if we click the button here, so then basically here is the request that we sent. So a few things. One thing is basically that you see that we send basically here the query and variables. So we have like two things. And the variables is exactly what basically we send with speaker, false, and this is basically the query that I send. Another thing is that this is post. So keep that in mind. I'll come back to that later. But also I remember that I forgot actually to show you why I prefer the schema first approach. So the reason why I like schema first approach is, let me just exit this one here, is because I can very easily mock it. So basically if I write first the code, and then from the code I create the schema. This means that whoever actually needs to consume my API needs to wait for me to actually push that to production. But if I have a schema first, I can write the schema, we agree on the schema, I give them the schema, and basically they can play with the schema, and create mocks and do their stuff while I develop the real API. So that's exactly what I did here. I have a mock server here. So what I'm going to do is I'm going to just, from this code, so source main resources, yes, GraphQL, no, schema. I'm just going to copy it. Let me just see if is that the right one? Yes, GraphQL mock server, data, mock schema. Basically, I'm going to do this. Then I'm going to run basically my mock here. I'm also going to show you the mock a little bit later. So then I can just go here to the local host 8000. And I get my whole, basically, mock. So what, again, like if we look at the documentation, again, I have the whole documentation, right? Talk with everything. But if I say query, this is actually what's going to see that it's a mock, all talks, and then let's say title, right? I'm going to basically get like dummy data. So that's again, like, for me, reason why I prefer schema-first approach, because I can just write the schema, and again, you saw how much time I need for a schema. It's like, what, you need like minutes, something like that. You give it to the front-end team or whoever's going to consume it and say, go nuts with it. They can basically then use the mockups, do their stuff, basically consume the mocks, and then in the end, when you actually like meet with both products, everything will work because you use the same schema. The code itself is not really that difficult, so I just need to open it. So let me show it to you. Okay, so it's not this one, so it's this one. A new window. So this is JavaScript code, unfortunately, but okay. So in a nutshell, it's a very simple thing. Here we just load some dependencies. Then here I just load my schema, and that's it. Here I have a query which actually is sent by the clients on an initial request to actually get the schema definition. Then here, what I do is I just basically take the schema, make it executable, add the mocks, and that's it. And then here I just basically define a very simple HTTP server, look at the URL. If URL is /GraphQL, I read the whole request, basically here, and when actually I finish reading the whole request, I say, okay, is it according to the definition of a schema? So is basically the front end asking for a schema? If yes, okay, send a response. If not, GraphQL just mock it, and that's it. So now I can kill this. And again, the only thing that you need to do is just copy the schema, and that's it. Oh, go away. I killed the wrong one. Oops, I killed the wrong IntelliJ. Oops. Okay, so I showed you a few ways basically how to, actually I showed you one way how to create a GraphQL Java. So let me show you now another one. Let me show you how you can create the same GraphQL API, but without using the Kickstarters. And also I think this is going to be very useful, because then you're going to actually understand more what's happening behind the hood and basically behind, like the whole GraphQL thingy. Eventually, when my IntelliJ starts up, see, that's a problem when you kill the wrong window. Come on. Okay, so let's open. Okay, data core 2. Yes. Okay, yeah, this window, why not? So this one, again, use Spring Boot, but it doesn't use the Kickstarters. And this one I'm not really going to code online live because I don't feel like it. So basically, again, purges, repositories, servers, everything exactly the same. So the first difference, of course, is that in the dependency management, the GraphQL is much, much, much shorter. Basically, we have like GraphQL core, and we have from the core just their Spring Boot, starter. That's it. The schema is exactly the same like the one that I already showed you, so no difference there. The Spring, like I said, I'm going to be using Spring Boot application, but as you can see here, basically, I don't do anything here. It's just my start application, nothing else. All the magic actually happens here in GraphQL provider. So what I actually do here is I auto-wire some dependencies. I define private GraphQL, and here I basically define the bean of a GraphQL. So the starter actually, well, not starter, but the helper from a GraphQL core team, actually, which I'm showing here, expect that it actually that you will define the bean of a GraphQL, and then it will expose it to the /GraphQL endpoint, and that's it. So the only thing that you actually need to do is create the GraphQL and basically create the bean, and that's it. And that's exactly what we do here in post constructor. So here, again, I read exactly the same schema like before. Of course, I just transfer it to the string. Then basically, I call the build schema, from which I basically get the GraphQL schema. And then basically, I say GraphQL, new GraphQL, add the GraphQL schema, and say build, and that's it. Basically, that's my bean for GraphQL. So let's look in a build schema, because all the magic happens there. Well, here, again, we don't do really a lot. So what we do is first, we say parse basically this string of a schema. And what we are going to get back is a type registry, basically type definition registry. This is actually like a tree of your GraphQL. So basically, it's going to read your GraphQL schema and say, okay, this is all the types that I have, this is all the connections which I have between them, and that's it. But again, we still need basically the business logic. So the business logic comes with the runtime wiring. Basically, here we just say, okay, give me the runtime wiring. That's basically the Java code, which needs to be matched with the type definitions. And then using schema generator, here, I'm just going to say, schema generator, make executable, basically, okay, here are the two parts. Here is the type registry, basically the schema, and here is the runtime wiring, basically the code. And that's it. So in our case, basically with the Kickstarters, all of this was done for us by the Kickstarters. So basically they say, okay, give me the schema, okay, I'm going to parse it, I'm going to create a type registry, I'm going to scan your code, basically on the fly create basically the runtime wiring, and basically going to connect them one-to-one, and nothing else. And again, if you look at the runtime wiring, it's going to be very similar to something that you already saw. So here I say runtime wiring, new runtime wiring, and then I say type, and basically this is my first type. And I have a type of a name, query, right? So that's exactly the same like this one here. So here I say, okay, I have a type query in my code. And I say, okay, in my query, in my type query, I'm going to have a field called all talks, all speakers, and all attendees. Again, all talks, all attendees, all speakers. So it's basically one-to-one. You're basically here, like, again, rewriting your schema in a little bit different way. And for every single field, you're going to provide with a fetcher. So that's like a small difference. So in the case of a Kickstarters, they call them resolvers. In case of a GraphQL core, so to say, implementation, they call it data fetchers. So if we look basically what a data fetcher is, if we just open this one and basically go to data fetcher, it's just a simple interface which has like functional interface with one method get. So here basically, okay, let's look what in our use case the data fetchers are. So if we call, okay, talk all, fetch all, like, basically we just say, okay, define the class, we put it as a component, so basically we can auto-wire it. We also like add some resources, like service in this case, and then I just say public data fetcher, fetch all, which say, and then it's like basically return data fetcher, and it's lambda to return talk service find all. So you're sending back basically the lambdas. So that's okay if we don't have parameters, like we don't have to like do any parameters or anything else. But what if we basically need to resolve something? Like if we go back to our schema, talk as a speaker, right? And this field is not part of anything. So again, core GraphQL by default will go find all the getters and setters and basically the same names and do it for you. Or if you basically provide it as a data fetcher, it's going to call it. So in this case, this field we need to provide as a data fetcher. So if we go back here, we here say, okay, we have new type, basically talk, and you see we only defined the field which is not already present in the project talk. Everything else will be defined by default. So we have a speakers, and let's basically, okay, open this one. And again, something which kind of looks strange maybe is that it doesn't get any arguments, right? So then how we know basically which talk we need to basically to resolve, right? Well, that's actually where the first parameter comes in place. So this is data fetching environment. This is your whole environment of everything which is actually happening at that particular moment in time. So here you can actually just say, okay, data fetcher gets source, and you get on what basically this basically resolving is happening. You can also, in this case, basically ask, okay, like what are the arguments? So basically just say, okay, data fetching environment, yes, get argument. So you can get arguments. You can basically get get field definitions. So you can basically get like selection set. And then basically here you actually say what's the whole query at this point of time. You can get the parent type. So you can basically get, okay, what's the class before. So with the data fetching environment, you have like everything exposed to you about basically GraphQL. You can basically do whatever you want to do here. So it's a very, very powerful thing, and you can do, you can go completely nuts. Okay, so let me just, go back to the previous code, so we can continue. And in the meantime, so we were a bit in it, right? This window. So I can also, what I can do is basically, so I can just go to data to core. That was basically the one which I showed you just seconds ago. So if I just build it and run it, let me also kill this Docker. Here. So it doesn't take resources. And basically, we compile it, we run it. It should behave exactly the same like the code that I was showing you before. Okay, let me also open this in presentation mode, so it's more nicer. So did it started? Yes, no, yes. Oops. So it started. Again, refresh. Oh yeah, it's not 8,000, it's this one. Refresh. So if I run it, you see I get exactly the same thing, and to prove it that's the different one, if I go to talks, you see there is no description there. So it works. Okay, so let's continue. Let's see what else we have. So like I said, the GraphQL has a very rich schema definition language. So what we can actually do in a very easy way is add something which I kind of struggled with the Swagger documentation, so to say. So my use case was very simple. We had like few endpoints, and basically we have like different resources. But for a business reason, on one endpoint they wanted to expose the whole world. And this was like like frogs and like oranges. And of course, with the rest, it's not really easy thing to do. But with the GraphQL, you can do it in a very easy way. So only thing that you need to do is just say here, union, and then you can say speaker. No, union, let's say all, the speaker, or it's a talk. So basically it can be either one or the other, because it's a union, right? Then we have add here all, and we say return back all, because it's as a type. And now, of course, we need to somehow define this. So let's do copy paste this one. And we go to the query, we update the query. So say public list. So what's anything in Java? Object, right? So we just put object, we say all. We don't have any arguments. So basically here, then we say, okay, list one. List one is what? Oh no, see, list one is, it was talks, right? Talk service. Find all. List two is, what was speaker or, yeah, speaker, right? Yeah, speaker. Speaker service, find all, that's it. So list one, add all. List two, that's it. Return list one. And that's it. So let's see if that's going to work. Okay, let's just build, and let's run it. So again, like defining something which is like can be anything, very simple thing. You just say union, you put a name, equal, and then basically you just put whatever you want. So you can put multiple things here. You can put like speaker, talk, attendee, whatever you have, and that's it. And then you can use this as any normal type, basically defined in a different way. Okay, so it's started. So let's run it. So in theory, it should still work. If my coding is still good, then you never know. Okay. Start, not yet. It's always interesting, watching like, starting the machine. Okay, so let's just refresh. Let's just delete this thing. Let's delete also this thing. We don't need it anymore. So let's say query. So now I want all. Cool, I can get all. But now we have a problem, right? Because, okay, what all is? Well, we can say on, okay, I forgot. On speaker. Basically, okay, say something. So we say like type, no, it's name, right? On, or basically we can say on talk, let's say ID and title, right? But just a second, speaker also has an ID, right? So we can say here ID. So we can run this, and then basically we say, okay, like, yeah, but we have like ID title, ID name, so how we figure out which one is which? Well, we can say, okay, this ID, we can call this speaker ID, right? And we can just call this talk ID. And now we know, right? Well, you can do this, or you can do something else. You can just say type name. And then basically, we get also like what's the type of the object that we're receiving in the union. So then basically the front end can decide, okay, this is of a type name this, I do this different type, I do different thing. Okay, but just a second, because in both things we have an ID, right? So can we actually put an ID in front? No, can we just say like type name, right? We can just say ID, because it's present in both, right? Well, no, not really. Because within union, we don't know anything. We just know, okay, the only thing that we can put here, which is always going to be present, is a type name. Everything else really depends from a type. So what we can actually do more here is we can also define a fragment. So we can say fragment, my fragment. On speaker, we can say frag name is name, and then we can also say like ID. So then we can just say these 3 dots, and basically we can say here my fragment, and that's it. When we run it, we basically get, okay, type name is a talk. Oh, because we have 2 times speaker, okay, my bad. So let's just remove this one. Actually, I destroyed it, so if just like this, okay, then basically we have frag name for speaker, an ID, and talks, we didn't define anything, so it's going to be completely ignored. Okay, so that's about how we can, combine different things. Again, one thing that, like I like to do, especially in Java, is if I have like different classes, and basically they share some things, like I want to basically somehow combine them to actually leverage that, right? We usually create an interface. For example, like if we go like, let's say attendee and a speaker, they're both human, so both they have names, so we can create interface in Java and just leverage that. Well, we can do exactly the same thing also in the GraphQL. So you can just define here, basically interface, we can call it human, and then we can say name of a type string. And then we can say, okay, attendee, well, it implements human, right? Speaker, it implements human. So one thing to be very careful about is that we can't remove this. So in Java, if we have an interface and we have basically something, we don't basically have to like repeat that in a class unless we really, really want to, right? Well, in the case of GraphQL, you have to. Which means basically here, I'm forcing attendee to have this name, and that this name has to be written here. If I remove this, it's going to be invalid and it's going to complain, as you see. Another thing that we can do is also then basically add here human, because again, it's an interface, we can say all humans, and we can return as a human, right? And that's it. So what I can also do is I can create, if I want, basically Java class here called interface, which is going to be human. Okay, which is going to say public string get name, that's it. And then my attendee can implement human. Okay. Then we can also have speaker. Speaker can also implement human. And then we can also, what we can say then, because I defined already all humans, right? All humans human. Okay, so then we can basically go back to the query and say here, what? Public list human. 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 Okay, you don't get any arguments, and basically I'm going to just do, okay. Yeah, I have to write it. List 1 is attendee service, find all. List 2 is speaker services, find all. That's it. And then we say list 1, add all, list 2, Okay, return, oops. Yes, comma, and then return list 1. That's it. And let's, oh, I forgot to kill this one. So let's compile the code, let's run the code, let's see if all is still good or not. Again, if I didn't make any mistakes, all should be good, but hopefully it's a demo, so everything works. Who thinks it's going to work from the first? Okay, now I have like 3 votes. Yes, you see, like, it's more than 200% up. You see? If I continue by the end, maybe everybody's going to raise the hand, right? So let's run it and let's see if it works. Did it start? No, yet? Not yet? Okay, so it started. So, again, refresh, very important. And now we can see query. Query all humans, and then we again say 3 on speaker, name Twitter, on attendee, name, right? We run it, and again, we get the same thing. So basically, this is attendees, and then as we get the speakers, again, we get name and Twitter. Again, here, we can do renaming, we can do filtering, we can use fragments. We can also, again, define the type name, right? Because every, basically, object has a type name. So we can just use this, again, to help the front end actually to decide what to do. But we can do something even more. So we can say here name, name, and then we can remove name from here, and we can remove this completely, and then basically just run it, and basically again, you see we have name for attendees, in case of a speaker, again we have a name, and we have Twitter. Again, we can, yes? I can't hear you, can you speak up? This one, but I think you can, again, like you can just say like, yeah, just, is that yeah. Yeah, because, so you can rename everything, basically, like it's completely, was this your question or? Okay. No. So basically human I just created because it's like fun. But like I could just go with the object, it's still going to work. Okay, so the question is basically like why I created the resolver for all humans and all, because we already have like resolver for humans, we already have resolvers for speakers, and basically can't GraphQL actually do one-to-one for us. So the answer to that is if you go back, okay, I killed the project, so let me just open the project again. So basically, if we go back to the one that I showed you, data C core, so basically without any core anything, new window, GraphQL doesn't do anything for you magically. So the only thing actually that GraphQL does for you is basically, okay, not this one, come on. So basically it only does whatever you told it here. So basically it just takes basically your schema, basically it parses it, creates the type definition registry, and then look basically for wiring. So basically again, and basically do one-to-ones. So it does something like this. So in this case, it's not, there is no magic clever, okay, saying, okay, you're doing the unions of the types which I already know how to resolve everything. Like, at least this implementation doesn't do that. And all the other implementations which I also looked, they didn't do anything magical about it. Like, they just really like do one-to-one. Basically, okay, like you have in your schema, this field, I will call that method, and nothing more. So basically, is it a union, is it an interface, whatever, it doesn't really go and do anything crazy. Again, I'll also like mention that later in the talk, but as you can see, the reason why I said don't push this code to production is because I don't do any caching here. So if, for example, I have a speaker which does billions of talks, and basically I say, okay, give me a talk, and for every talk, give me a speaker, I'm going to call that speaker like a billion times to the database or any other system. Also, one thing to keep in mind is that in my demo, I'm using the database as a backend. But again, as you can see here, I'm just saying, basically the GraphQL what does is say, okay, like I have this field in the schema, this is the fetcher or resolver, however you want to call it, which is actually going to do the business logic. And the business logic can be anything. So it can be something like this. So it can be basically going to a different API, it can go to a different server, it can go to the messaging, it can go to the database, it can go all over the place. So you can also have real use cases. That's actually where the GraphQL shines the most. Is let's assume that we still have like exactly the same like situation. We have like attendee, we have a speaker, and we have a talk. So let's say attendee is in a database which is local there. But the speaker is in basically some third-party system that we need to call over gRPC or over the messages. And then basically the talk information is, again, some old mainframe, which is like somewhere in the basement, who knows where, nobody is afraid to touch it, written in COBOL. So that, again, GraphQL is just going to basically make those calls, depending on what the user actually sent in their request, going to basically combine them and send back to them. But again, we need to keep in mind that it doesn't do any magical stuff for us. It's just going to do this. Okay, you want all talks or whatever, basically, okay, I'm going to just call this method here. And whatever this method does, I'm just going to do it. So I don't care about the performance, I don't care about security, I don't care about anything else. I'm going to call this method and provide it with a basic environment that if it needs something, it can take out of it. But it means that we need to keep in mind and remember, okay, what actually is happening in the background to make sure it's like secure, that we had the caching and all those kind of things. And also in this case, if there is a union, GraphQL doesn't really care. It's like, okay, it's a union, you deal with it. You basically resolve it in a way that you want to resolve it. Maybe you want to add some additional parameters there or something like that. Does that answer your question? Okay. So let me go, to this one. Okay, so where we are now. Okay, so we have like humans basically. So like I said, if I don't create a human interface, it's still going to work. But again, it makes sense to keep the code very nice and clean. So if we go back to, let's just kill this one, to this one, and we go back to GraphQL query language, so far we were only reading the data, right? So only read only. And as we all know, if only thing that we can do is just read the data, it's going to become not fun very fast, right? So we need to way also to change the data. For that, we use mutations. So how we do the mutation? So before I actually show you mutations, again, one thing that you need to remember is query is read-only, which means it's going to be run in parallel. It's going to be optimized. Mutation is changing the data, so it means it will be run in sequences. So keep that in mind. So if we go back to our schema, so let's just say, okay, we have basically, again, we go to the query, basically to the heart of a GraphQL, which is schema, and we add here mutation, mutation, that's it. And then what's a mutation? Well, mutation is a type as any other type. So we can just, oh, I'm in the wrong one. Okay, so let me. So you see, that's why I don't like when I have two windows. So this is data core. No, this is init. So this one needs to go away. So yeah, so this is the right one. View mode, presentation mode. Okay, so we go back here. Yeah, so we have basically here the heart. Where's the heart? Yeah, schema. So we say here mutation, 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 mutation. Then we basically here define the new type. Type, mutation. And what we actually need to do is, let's say we want to say add speaker. And we're going to have a name, because we need to have a name when we add a speaker, right, of a type string. And it's going to return us a speaker. And that's it. So basically, mutation defined. Well, that's for a schema part. As we always say, we have a schema part, then we have like basically the code, which actually needs to wire one-to-one. So again, you don't really have to also, I'm not sure if I mentioned it or not, but you don't have to call this mutation and you don't need to call this query. As long as basically the same names you use also like in the backend. But again, so you can call this like my magical pony, if you want. But again, if we keep query and mutation, that whoever opens the code actually knows, okay, this is what it does. So let's say then add mutation. Again, we go to resolver. We add new class mutation. So what we actually do here, again, let's say first add required our constructor, and then here we're going to implement GraphQL mutation resolver. So then again, keep this in mind. So again, this is one of the helper classes to actually help us, okay, like define what we are doing. So if we go with the query, it's GraphQL query resolver. If we resolve something for some type, basically then it's just GraphQL resolver with the type for which we want to do. And for mutation, it's GraphQL mutation resolver. So what I know that now I need private final, well, we're adding the speaker, so we need speaker service, okay, that's it. And then we need basically to add the exactly the same method like we were having here, which is add speaker, right, with a string, which returns speaker. So we say here public speaker, this one, right? So it's like we need to import the speaker, of course. Then method name speaker, its type is string of a name. So here we actually have a parameter. And then here we have speaker is new speaker. Set name. Or actually, they already have like the class set name speaker. Oh, name. Yes, name. And then I say return speaker service. Save speaker S. Okay, cool. And basically that's it. Last but not the least, of course, we need to add it here in this one here. So we basically need to add it here. New mutation, and then we say, okay, let's import this, and we have speaker service, right? So if we compile the code now, so one thing that I want to also make sure that you understand 100% correctly is that this way that I'm passing the parameter to mutation isn't mutation specific. So this is the standard way how you actually pass the parameters. So I can use exactly the same approach like here to also send, basically pass parameters to the queries. Because in my case, again, like I said, not for production, every single time I'm reading everything from a database. And again, GraphQL doesn't care. It's just going to say, okay, this is basically the method, this is what you need to call, and that's it. So if you want to do paginations and things like that, or filtering, or maybe ordering, things like that, you can basically send additional parameters, but then you need to basically do it on your backend system. So basically say, okay, I'm going to get like parameter of a type int, which is going to, for example, be a page size or page or offset, things like that, and then basically in the backend actually do the part and send appropriate response forward. So GraphQL will not do it for you. But again, with this way, you can send as many parameters as you want, and then basically deal with whatever you want to do in the backend, do with them. Okay, so it's compiled. Let's run it. So again, what we did. So we just defined in a schema mutation of type mutation. We defined exactly the same like so far. Basically, just add speaker. In this case, we're adding the parameter. It's going to return best as speaker. We defined mutation, which implements GraphQL mutation. We defined the method basically which does the logic for us, and we added it here, and that's it. So not really a lot of code, basically. Okay, so it started. So again, let's refresh. So let's now say query, if I know how to write, all speakers. Let's say ID and name, right? And basically here we have like 4 speakers. Okay, so let's add a new speaker. So we say mutation. Okay, so add speaker, and we say name is, Devoxx, right? So what's going to happen in this case is we're going to basically get speaker. So it means we can say for ID, we can say the name, we can even ask for Twitter, right? Why not? Because it's a full speaker. And if we run it, basically see ID is 5, name is there, but Twitter is null because we didn't define it. Okay, so before we continue, let's actually clean a little bit of code. Or actually, oh, no, let's do that later. So what you can, again, look at this, say, okay, like, yeah, but what happens like if my speaker object is like very, very big? So I need to like send like billion of parameters. This is going to become very large, right? Can I actually send something like speaker here? Let's just call this instead of name, just say, okay, let's say speaker, and then basically add here type speaker, right? Like we do with the JPI, right? We just create a now Peugeot, we don't put an ID, and we just basically fill in what we want and just send it to the JPI, right? And say, okay, do it for us. Well, yes and no. So in the GraphQL, you can't do it like this, because types are for reading data. However, what you can do is say, basically, let's say input, and you can say speaker input, and then basically we can go to the speaker. Where's the speaker? Copy the things that we want. And then we can say here, speaker input. So this, yeah, this we can do. So like I said, types are reading only. Basically, if we want to actually send the whole object as an input, we need to create an input object. It's like input type, so to say. So let's define that one. Again, we can just push it in the Peugeot, why not? Try class, Peugeot, speaker input. No, I don't want to add to Git. Again, let's add data, Lombok, because I'm a lazy person. Again, let's just do the copy paste. Actually, I can do copy paste from the speaker. Yeah, that's even better. I get all the right types and everything. So, okay, speaker input. Okay, but then, basically what we need to do is we go back to mutation. So now we don't get a string, we get speaker input. Speaker input, it's SE, right? Speaker input for short. SE get name, say speaker, set Twitter, SE get Twitter. Okay, that's it. So let's now kill this one, let's compile the code, and let's run the code. So, to recap what we did, basically we went to the schema, basically we changed the parameter from a Scholar type to basically to like type. But again, we can't use the type itself because types are reading only. We need to create an input. So we defined an input. We called it speaker input, and we just basically have fields that we care about. So that's what we did in the GraphQL schema. Then we defined basically the simple Peugeot, which has the fields that we need so that we can use it in the Java code. In mutation, we basically just added this as an input parameter, so it's speaker input SE, and basically we did this code, nothing else. So this is compiled. Let's now run it. How I'm doing now? Like, who thinks this is going to work from first? Okay, okay. It's like now almost 7, 8, 9 people. So it's like you see, like it's like exponentially growing. So by the end, everybody's going to raise the hand. That's good. Again, remember, like if anybody is showing you any kind of demo and it doesn't work, then they made a big mistake, because all the demos should work from the first. Yeah? That's the whole point for a demo. Okay, so let's now refresh. Again, we refresh. So now what we need to do, again, let me just show you that it's going to be clear database, because I push, again, the same data every single time. Okay, so it's ID in name, okay. So again, we have like only 4 speakers, so we refresh the database every single time I restart application. So let's say mutation. Now we say add speaker. So basically now we're going to say speaker. Name is going to be Devoxx and Twitter is going to be, yeah, it's also Devoxx, I think. And then what we get back is ID, title, Twitter, and the name, right? And if we run it, voila, it works. Perfect. So I showed you basically how we can read the data. I showed you also how we can, change the data. So the GraphQL query language consists of 3 parts. So reading data, query, changing data mutation, and there's the last part, which is called subscription. So subscription is very similar to the query. The only difference is that in case of a query, we send basically we send single request to the server from a client side, and we get single response back. But again, in case of subscription, it's a little bit different. We send single request, but then we get back stream of messages back. And if we go back to the beginning of a talk, GraphQL actually came from a Facebook. So it's very logical to think from where their use case actually came from. Like news feeds, friends feeds, all these kind of things. Basically, you send like I'm interested in these people, and basically then just send me the information as they're coming. So let's define that in the code. But before we define that in the code, let me show you the third way to actually write the code in GraphQL. So I showed you one way, which is basically with the servlet, right? I showed you the way where it's like simple GraphQL Java core without any other Kickstarters. But let's show you the third way. And for that, let's first go to the POM. So let's uncomment this part here. Oops. So uncomment this part here. So this is, again, Kickstarter Spring Boot starter. Now, I don't need this servlet, but let's just keep it for there, enable auto import. So what I need to do is now I go here, and basically I need to clean up the stuff. So let's just remove this. So we don't need this. We don't need this either. Then query, basically we don't do this. We need to actually say component. Then this is not final. This is not final anymore. So now we just need to resources, okay. So we are basically now cleaning everything. We're just creating like now the pure Spring application, so to say. So you can also use out-to-wire, resource, whatever you want to do. Again, mutation. We again remove this one. We create this as component. We remove the final. We inject. Oops. Yes, of course. Yes, please. So query already did. Talk resolver, again, same thing. Component. So this is like the third way that you can actually do the GraphQL Java. So basically you can say, okay, that should be that. Let's just compile the code and just make sure it still works before I continue. So like I said, there are multiple ways that you can actually implement the GraphQL Java. Even you see in a Java using the same Java implementation, there's 3 ways that I can go. So I can go pure, basically, GraphQL Java, do the whole wiring myself manually. I can use the Kickstarter with the servlet, which basically then I can just plug in into any servlet. I can do it basically with the J2E, I can do with the Spring, whatever, and it does work for me. Or I can even go pure Spring way where I have only components, and basically then the Spring does all the magical stuff behind for me. Again, it's not really magical, as you saw in self. It's just wiring, basically, connection of your schema to your Java code one-to-one, and that's it. So everything else still comes basically back to us. We still need to basically think about everything there. Okay, so let's see if this one started. Okay, so this one is started. So if I just refresh, and let's see query, say all talks. Oh yeah, well, let's say all talks. I prefer talks. Talks has an ID, title, speakers, and then the speaker has a name, right? Yes, and if you run it, voila, it still works. Perfect. So we're still good. So now we basically have pure GraphQL, basically pure Spring, so to say. So let's add new resolver. Actually, no. First, what we need to do is we want to go to the schema first, right? We go schema first approach. So we add subscription, like I said, and type subscription. So we go subscription. Again, we define the type subscription like any other type. Okay, we go with the type. Oops. So what we have here, well, let's imagine we have scores, right? So we have scores for talk string. So basically, let's say we basically want to see how the scores for certain talks goes, because you can score the talk, right? Hopefully, you're going to score this one good. So we actually just put basically the title of a talk. This is talk by title. Yeah, my bad. Title, and then we basically get back the scores. So you could think that we should put array, right? But no, that's not the true. You just need to put a single, basically, value score, although it's a subscription. So now, also, I need to define the type score. So I can say, well I have a title of a talk, which is string, and I have a score, which is an int, and that's it. So basically now we're done from the schema part. Now we just need to write all of this code in Java. So let's go first thing first. Let's first add the score. We go Pojo, Java class score, right? Okay, go away. Again, I'm lazy, so let's just add data. Let's add builder also. Yeah, because again, I'm a lazy person. So what the score has, again, the easiest thing is just do copy paste. So copy paste for the win. And also then you don't, you see, you don't do like what I did, errors in typing. Yes, come on, man. Yeah, there is a G at the end. Okay, okay, then we have a score, again, private int. Okay, score, that's it. So score is done. What else we need? Well, we need subscription, of course, right? And again, subscription is going to be resolver, so we go back to our good old resolvers. Say new class, resolver, subscription. What I say also, I want component, right? So that actually Spring can actually find it and do the, everything that needs to do. Also, it's going to implement GraphQL subscription resolver. So it's, again, basically Kickstarters are very logical. So for query, we have GraphQL query resolver. For mutation, we have GraphQL mutation resolver. For subscription, we have basically GraphQL subscription resolver. For everything else, we have just a simple GraphQL resolver with the type for which we do resolving. Another thing that I also need to do is, because now we're going to go creating the streams and everything being reactive, I need to update the POM. So I'm going to add new dependency, and it's going to be RxJava. Yes, yes, this is the one. And the version is going to be 2.2.3. Oops, 2.2, yes, 0.3. This is the one, cool. Okay, so now it resolves the dependencies. So now we have a subscription, but we still need to resolve the things that actually subscription does. And that's like scores, title, string. So now, if we just do the copy paste from the code, we would say probably public score, and then we do this, right? Let's just import score, and score title is actually string, and then title, and then we do the code, right? Well, this would be wrong. We didn't do this. So we actually return the publisher of observable. Publisher of observable. Observable, yes. So then here we create observable. Yes, observable, yes, with observable create, and then we say here lambda, and that's it. So for now we can actually leave this. So what else then we do? We basically create connectable observable. Well, we do observable share publish, yes, which is basically connectable observable, yes, basically define the type, yes, connectable, yeah, I don't do the good type. Then basically we say connect, it's funny, but what can you do? And then we say return connect to flowable buffer pressure, yeah, buffer pressure strategy buffer, yes. That's it. So basically with this, we say, okay, we are creating observable, and then here we're going to define actually what's happening inside observable. We are connecting to it, and then we're actually creating the flowable from it so that we can create a back pressure, so that we don't kill the client on the other side. So now the only thing actually left for us is actually to get the data. So I'm going to cheat and just basically say scheduler executor service, executors dot new scheduled thread pool with 1. So basically I'm just going to create like a cron job to actually generate the data for me. So I'm not going to really like do some crazy stuff. So I'm going to say scheduler, schedule at fixed rate. So basically we're going to again do lambda here. And then we're going to say 0 to time unit seconds. So every 2 seconds, I'm basically going to run this lambda here. So basically what I'm going to do is I'm just going to say score is score.builder set title. No, title. Yes, title is title, which actually I got from beginning. Then I say score. We'll put this something here. And then we say build. Come on. Okay, then let's write this code here. So we are going to actually say, okay, math. It's random. Multiply by, I think it goes from 1 to 5 here, right? Yeah, 5. So 5, but then let's just math.floor, yes. Basically, because we can have only like integer numbers, basically like 0 full numbers, and then we say like, okay, this one is going to be int, because we put as an int. So that's it. So this is the one, right? And then we say build, yes, that's it. And then we say E on next, score. That's it. So, why is subscription red? Ah, I didn't put here. Yes, now it's all good. So, this is the last demo. So let's compile the code. How many people think that this last demo is going to work also? Come on. Yeah, everybody, yes. That's it. Thanks. It means a lot to me. So let's see when it compiles and it runs. And let's see if it's basically if your fate is like well placed or not. I hope it is. Okay, so let's just go back and like just quickly go through the code. So basically what we did is we just defined, again, in the heart of a GraphQL, subscription. We defined the type subscription exactly the same like any other type. We just say the scores, basically here you can pass the arguments or not. Important thing to remember here, you just put a single type of basically what's going to be coming back as a stream. So you don't put an array, and that's it. Then we defined, of course, the type score, which is very simple. Peugeot, and then in subscription, we implement GraphQL subscription resolver. Important thing, we are pushing basically push a publisher observable, where we actually just create observable here. We added here some code, which is going to, every 2 seconds, create a new score randomly. Then we connect it to it, and basically put it as a flowable, so that actually we can use the back pressure. And it crashed, yes. Yeah. Yeah, score. Is it score? Yes. Just a second. Observable title. Oh yeah, my bad. You see, so your fate was flawed. Observable of a type score. So now it's going to work. Sorry, you all had the faith in me and it didn't work. This is actually the first time that this demo didn't work. Like all others crashed. So far, this one was the always like, you know. What can I say? But again, like I always say, you know, like whenever you do live coding, it's always interesting, right? Because if it works, then it's like awesome. If it doesn't work, then we all do like debugging together. Like let's see, like where's the error? What's did I miss actually the code or something? Actually, I did like talk like about 2 weeks ago where I wrote all the code, everything was correct, but it was in completely like like different package. So then everything else like went to hell. And I was like, why? It's like all the code is there. So live coding is always interesting for both sides, both for you and for speakers. So come on, doesn't work again? Okay, now I'm. Okay, so publisher observable scores. Well, it shouldn't register what? You mean the score or the subscription? Well, it shouldn't be because it's component, so it should be picked up out of the box. So it's component, implements GraphQL subscription resolver, public publisher observable. Let's actually check the notes, because the notes are always good. Oh, yeah, my bad. Score, this one. Oops. Yeah, now it's going to work. So as you can see, I don't do like subscription very often. So basically, the problem was that actually I created a publisher of observable instead of publisher of a score. And yeah, what can you do? Now it's going to run. The third time is the charm, right? If it doesn't work again, then we go to the code which is already prepared and which works. So that's why I have all those directories, integer, data 1, data 2, data 3. So in case I make a mistake, I can just, oh yeah, look, this is the right code. But also it helps to select the steps. Okay, so now, yeah, it's running. And again, where's my thingy? Again, we refresh again, like always. So we say subscription, scores, let's say title is great talk, right? And then what we get back is title, and we get a score. So if we run it, basically what happened now is the GraphQL is opening the WebSocket, and over the WebSocket is connecting basically to GraphQL API, and basically then the data should start coming back. Maybe? Yes, yeah, it's coming. So you see, it's coming. So, for example, this part here is well, it's not really new, but it's relatively new. So when I first started actually doing the talks about the GraphQL, and of course I did it in Java, subscription wasn't implemented at that point. Then during one talk, somebody told me, okay, they implemented it. So then I also looked into it. So again, when it comes to specification, subscription isn't really defined how it should be done. So it's like there is no specification saying, okay, you should do it over the WebSockets. But again, GraphQL Apollo team basically implemented it over the WebSocket, and then everybody jumped, well, at least majority of people jumped on the same train and basically also implemented it using the WebSockets. But for example, this is one part where actually, again, implementation can differ. Okay, so we basically looked at the query, we looked at mutation, we looked at subscription. So it's all great. Oh yeah, actually I forgot one very important thing to implement. See, so one more thing that I want to do, actually to show you, is, okay, so we go from talks, we have speakers, right? But can we also connect speakers with the talk? Well, yeah, why not? So one speaker can have multiple talks. So again, we say array talk. So that's that. Then again, we do resolvers. Now we have speaker resolver. Resolver. Cancel. Again, it's component. So it implements a GraphQL resolver. Yes, for a speaker. Speaker. Okay, implement, please. Import, yes. Then we say resource, yes. Resource, private, talk service, yes. Talk service, yes. Thank you. And then we say, where's the, it's talks, right? Talks, cool. So speak resolver, so again, we say public. It's going to return list of talk. It's going to be called talks, and it's again getting the object speaker. So whenever we form the speakers, basically we called the field talks. It's going to call, what the hell? Yeah, just import. Basically going to call this method, and this method is going to say return talk service, find all talks by speaker, and that's it. So again, now we compile the code, and now it's going to run. Actually, let me just check. So it's component, speaker resolver, implements GraphQL resolver for a speaker. That's good. We have a method called talks, speaker, cool. It should be working. Compiling, let's check. So this is actually the last demo. So let's run it. So now I'm going to actually show you one thing that you can do very easily. Again, the whole idea behind the GraphQL and why it's called graph is that you have basically your types, and you're creating basically dependencies between them. So you're creating like a graph between them. So we already created the basically connection between a talk and a speaker, and now I'm creating also connection with the speaker and the talk, because again, you might see, okay, like this speaker is great. Let's see which other talks he has, right? So we want to find out. Again, we refresh. We go query. We go all speakers. No, all speakers, right? We say name, and then we say talks, right? And then we say title, right? So let's see for all the speakers, let's see the talks. Cool, it works. But just a second. So this here is for talk, right? So talks have speakers, right? And speakers has a name, right? Okay, it still works, right? But then the speaker has talks, right? And it has a title, right? And it has the speakers. And the speaker has a Twitter, let's say Twitter this time, right? And again, it says talks as a title. So, and it still works. So this is one thing that you need to be very, very careful about GraphQL. So basically, again, you can have a cyclic query. The cyclic query is basically the query where you have like basically like going into loops. So in this case, we have always going from a talk to the speaker talk, and always coming back and back and back. Reason for that is simple. We had a talk and we had a speaker, right? Two types, independent. And then we say, okay, let's connect the talk with the speaker because it makes sense. We want to give more user-friendly basically things to our front end. But then we also wanted to go from a speaker to the talk because again it also had user-friendliness, and then we ended up in infinite loop. So if you're not careful, you can very easily create cyclic dependencies inside your GraphQL application. And again, like the one thing, again, like because most people are familiar with the REST, that you need to remember when it comes to the GraphQL is that, like in the case of the GraphQL, client call all the shots. Because in a REST, basically what we do is we just define, okay, like these are endpoints. Basically, this is the things basically that we expose, right? This is basically where you can actually hit, send certain parameters. And then we know exactly where the user is going to come, what's the path through our code. That's not the case with the GraphQL. With the GraphQL, basically we say, okay, this is, oh, I was sitting too long. Basically, this is all the types that we have. Oops. This is all the connections between the types. And then you, as a user, decide what you want to do, which things you want to call, if you want to rename it, which parameters do you want to get. Like absolutely everything is at the fingertips of our users, which is a good thing because the user has much more power. But also, it's a very, very dangerous thing because, for example, like if you push this code into production, somebody can send a ridiculously long query with a cyclic dependency and just going to take the whole system down, especially because I don't have any caching, I don't have anything. Like basically, I don't have a single protection point in my code base. That's why I said it's only for demo purposes. So the thing that we also need to think about and be aware is, okay, like how we protect ourselves from abuse. Because again, by default, GraphQL doesn't really going to provide you that. Again, depending on the implementation that you use, you might already have some protections layers built into it, but they don't come always by default. The simplest way that we can think of is basically say, okay, we can just do the timeout, right? So we just do the timeout, and basically, okay, after the timeout, basically we just kill the connection, say, okay, send to client, okay, like 404 or whatever. Well, that is protection, but not really. We are going to send requests back to the client relatively fast. However, we're still going to basically spend the cycles, memory, resources, everything on our side. So we're not really protecting ourselves. So what we can do is actually say, okay, let's define what's the maximum query depth. Because if you go back to almost the beginning of a talk, what I said is, okay, when the query comes to the GraphQL API, what it does by default is validate the query. Is it according to the schema? So there, very easily, we can just plug in our code and basically say, okay, check also like what's the maximum depth of a query. If it's above some number, just don't do it. Again, some implementations have it out of the box already built into it. Some of them basically just have basically like the hooks for you to actually do it. So if we go, for example, in our use case, let me just show you the code. Okay, so basically in my, oops, I set on the wrong cable. So in my case now, here I don't have really data fetching environment, right? Like I had like in the code that actually I showed you before, where we just use the plain queries. Well, actually we do. what we need to do is just say here, data fetching environment, CTX, and that's it. And then here, basically, I'm going to have I'm basically having, and I can do, again, do things, exactly the same things like I did before. I can say selector, get selector, selection set. I can do all the things, basically, I can say selector, get fields, and basically here, I get the whole query, what happened at this point. So I can say, okay, it's like too expensive, it's too long, not too long. So this is basically my hook to do whatever kind of logic I want to do. Because the only thing is I just need to add this one, and that's it. So in this case, there was no argument, so it's easy for me to add it. But what happens, for example, in speaker resolver, where we already have an argument, right? Well, you just add it at the end. And that's it. And then just go and play nuts with it. Again, with this thing here, you will have complete context of what's happening. Where in the tree of execution you are, what's actually happening, what's basically going to come next, what's coming actually before. You have whole power of it. So you can actually protect yourself. Again, it's not the easiest thing to do, but again, like you have all the hooks. Again, depending from implementation to implementation, you might have already then done for you automatically. Okay, so that's basically if we go with a very low depth query, right? But what happens if we are attacked like in the width? I'm not sure if I showed that or not. Okay, this is still running. Okay, it's still running. So what I can also do, I can say, okay, do this, right? But also, I can say now, I can also say now all talks and say basically title. So I can also do this. So you see, and I can add then all attendees, right? I can say name, right? So I can not only be attacked, basically using, like the depth, I can also be attacked during the width. So in that case, this one will not protect me, right? So better approach for protection is to actually have, max square complexity. Where for every part of a query, again, we say, okay, this is what the complexity is. Then we basically, again, during the validation of a query itself, we just basically, sum all the numbers for every single part of the query, say, okay, this is the sum. If a sum is too big, we just don't do it. Again, some implementations have already this baked into it. Some just basically have the hooks for us. So again, it comes back to basically implementation itself. So that's why I said you need to think about, basically, you need to know which implementation you're using. The best approach, also like the problem with this one is that in this moment, basically you implement it, right? You know exactly what's happening in the backend. You know how complex it is. Is it like calling some backend system, which is going to like take for ages? So it's very expensive, or it's going to like a local database, which is very fast, or we're just going to the cache. But what happens is like in 1 month from now, 2 months from now, if you change the code, will you remember to also update the complexity? If somebody else comes and basically changes something along the way, will they also know how to, update the complexity? That's the tricky part with this approach. So it's a great protection, but again, keeping it in sync can be difficult. The best possible approach is that we just do the throttling. So basically, for every request, we give basically a certain amount of CPU, a certain amount of memory, every amount of time, like regularly. So if somebody sends like ridiculous query request, it's going to take forever to actually be done. But again, to implement this, it's the most complex and most difficult one. And as far as I know, it doesn't come out of the box with any implementation. So again, when we thing that I'm always very often asked is, okay, what happens about the caching, right? So if we go, for example, in our situation, we have like, let's say we have a speaker, which is a really great speaker, so he has like millions of talks, right? And basically we search for all the talks, and then for all the talks we actually ask for a speaker. In my use case, we're going to go to the database 1 million times to fetch that speaker. Not great. So can actually GraphQL help us? Well, it depends. It really depends from the implementation that you're using. Some implementations already have some, caching logic built inside it. But again, like maybe, for example, in my case, the GraphQL Java doesn't do anything for me. So from caching side, there is no help at all. But again, because I'm actually in control of everything, so it doesn't matter if I'm using with the Kickstarters, basically, or I'm using the plain Java. Basically here, whenever I call the service, for example, I can just cache that call, like we actually do from the controller to the service. I can just add the caching there. Or maybe, again, because I have the whole data fetching environment, I can see, okay, for example, I already executed this whole query, exactly the same query, so I can even cache results basically from the whole queries. So there are all kinds of different ways that I can actually add the caching myself. But again, it doesn't come out of the box, at least in case of my implementation. Another thing that also I'm very often asked is, okay, what happens with authentication and authorization? Well, again, it depends. Again, if we go pure GraphQL, real specification case, GraphQL doesn't care about caching, it doesn't care about authentication and authorization, at least at the moment. So it's up to you and implementation that you're using to actually protect yourself from that. In the case of a Java GraphQL, what we need to do is create basically something like this. We create class myGraphQL_context, which extends GraphQL context. And then basically, we just add some things that basically we need here. For example, user, credentials, roles, whatever. And then basically, in the method itself, again, like I said, when the user basically accesses our website, we check if it's basically logged or not. If it's logged, basically we provide them with some session ID or whatever. And then in the method itself that needs to do resolving, again, we add data fetching environment at the end. And then we get the whole context of environment. And then basically from there, we just say, get me the context, and we will get our custom context. And then here we can say, okay, check, for example, if the username basically is validated, if he has right access to actually do the things that he actually needs to do, and we can decide upon that, okay, do we actually execute the query, or we just say sorry, you don't have enough rights, go back. So the problem actually with this doesn't solve is when we want to actually protect schema itself. Because in the GraphQL API, schema by itself is completely publicly open to everybody. So if you want to protect, which is if you're a hacker, it's if you know that something exists, it's already half of battle won, right? So if you want to actually protect who sees the schema and certain parts of a schema depending on the roles and some access, then it's much, much more tricky, and you need to go really deep into implementation of a GraphQL and basically do some stuff there. For example, I know that there's also approach with the directives, and in some cases, some implementations actually added some add auth. So for example, I have here. So here I use the include, right? So I use this. So basically in some cases, basically they use add auth, and then here basically they say, okay, this is the role that the person basically needs to have in order to be able to access this field, see this field, and all those kind of things. The problem with this approach is that it's not standard. So it means that if you use that specific implementation and the client which actually understands that specific implementation, everything is perfect. However, if somebody tomorrow, some other client comes and it doesn't use that specific implementation, you're in a world of trouble. So that's why I personally don't like that approach. I like let's just use what's in the spec, because then we're 100% sure whatever library, whatever implementation, whatever client actually we talk to, everybody will be able to use it. But again, as far as I know, this part is on the roadmap for specification. When it will be handled, I'm not sure. Okay, so you remember that actually I showed you during the query, is basically whenever I send a request from a GraphQL to my server, that it was post, right? So first time when I saw this, basically, okay, I was playing with the GraphQL, everything was perfect, this was fun, this was very nice, finally, I can just basically make my backend system very nice the way that I want to, expose it to all the users, and then basically they can just take whatever they want to do. So there's no overfetching, no underfetching, all those kind of things, because always there's how basically we provide them with the fields that they actually need, but not the others. But then I saw, okay, but just I just looked, okay, what's happening? Okay, so I'm sending the post, and I'm sending in post payload with a query and variables. Okay, query and variables, that's okay, because I need that, right? But post, to read the data, come on, then it means I can't cache it in any load balancers, firewalls, basically any other systems that, again, the clients don't go directly to my machine. They go through multiple layers before they come to my machine. So does that mean that then I need to cache everything, even though it's read-only? Well, not really. By default, and this according to the specification, query works with both get and post. So that's when I read this, I was like, ooh, that's good. So basically, I can just say to them, okay, if you're reading the data, send the request over to get, and basically everything still works. I'm protected. Basically, all the layers which we built with the years and years before are going to help me. If you're changing the data, then yeah, it has to be post. But that's a logical thing, right? Another question which I get very often is, okay, but in this demo, we basically put every single thing into the same schema, right? So basically, we did not really that much code, right? And we already have like, what, like 60 lines of code for like, in schema for almost nothing, right? And this is like peanuts, let's be honest, for like real production systems. And again, if we're going to use the schema in a way that basically we're going to put it like a gateway, let's see, eventually. Yeah, if we're going to use it like this, like a gateway for everything, well, then that schema is going to become huge, right? Because what I'm going to do is I'm going to look at all my APIs, all the things that they actually expose, all the types. I'm going to put them in the schema. Then I'm going to look for like databases, like other servers, things like that, put all those types into schema, then make all the connections between all those types. The schema is going to become huge, right? So then what should we do with the, huge schemas? Like, is that way forward? Like that we just have like one enormous file like, to rule them all? Usually that doesn't end up very good, right? Well, at the moment, there is no uniform way actually how to solve this problem. So it's a problem. Everybody's aware of it. At the moment, there are different ways actually how to solve it. There is no solution which says, okay, like this is the standard way, just go this way. One way that you can actually do, for example, that it's a normal approach, especially in the JavaScript community, is that you just basically open multiple schemas and you just combine them because that's like strings, and then just pass them to the server. So we can also do the similar thing in our Java code. So we can just say, okay, new schema parser, right? And then we say schema generator, just put it there for now. And we say load schema, basically we load the first part, put it in a file, load second schema, put it in a file. Then basically we say type definition registry. If you remember last time when I actually showed you the code with the GraphQL Java only, we basically parsed the SDL, basically the schema, and from the schema we got the type registry, type definition registry. But here we just create new type definition registry empty, right? And then we basically parse the schema, and that's what we actually parse, we merge with this type registry. And again, we do the same thing for a second file. So basically we do almost exactly the same thing like JavaScript community. We just load one file, basically we parse it, we push it, we load the second file, we basically also parse it, and we just merge it with whatever we read already. And in that way, we can basically split the schemas and do different stuff. In the end, we just call schema generator, make it executable, again, type registry, and runtime wiring, and basically just combine them. So that's, yeah?
What about the same names?
There can be only one. So one is going to win. Actually, also like, so I'll come back to that. So that's one way. The other way is that you, okay, so yeah, I'll come back to that. So that's one way. Another way that you can actually extend, you can also extend the types. So what extend actually means? It means basically you can have like type, speaker, which implements human, right? It has an ID of ID and the name of a string. So tomorrow we can just extend it by writing somewhere in some schema somewhere else, which is going to be combined with the original schema. Something like this, extend type, speaker implements human, IDs of ID, names of string, and we add also Twitter. For example, let's say we want also to see the attendees' Twitters. As you can see here, we have like double the stuff that we have in speaker, right? So we can just remove that, and again, GraphQL is going to be clever enough to know it's actually going to do this for us automatically. So if you see extends type and see fields that are already there, it's just going to remove it and just add the new field. Additional way how you can actually also combine multiple schemas is actually schema stitching. At the moment, this exists only in JavaScript world, but I probably is going to come into Java world also. What it actually means is you have multiple GraphQL APIs somewhere in the backend, and then basically all of them basically talk to a single GraphQL API in front, and it's on the fly going to actually merge all the schemas. And it's going to expose like one big schema to the front-end users. In this case, it's going to be exactly the same thing like you asked. Okay, so what happens if, for example, we have like same type in these schemas in like multiple GraphQL APIs here? Again, there can be only one. So actually, during Devoxx France, I spoke with one person. They're also using very heavily like GraphQL in production. And they go from the code first approach. So basically they write the code, then from the code they generate the schema, and basically they have like a lot of GraphQL APIs, which then basically they do the stitching, and basically then expose that huge GraphQL to the front end. And I asked them exactly the same thing. Okay, like, but what happens basically if, because you have a lot of teams building this, right? So how you make sure that, one team doesn't put like some name, and the other team also doesn't put the same name, because like what's going to happen then? And he said, well, because we're afraid of that, we do very rigorous control of all the schemas that's actually going to be produced. And we're basically in that way making sure that there's not two different APIs using the same name, because there are going to be conflicts. And then one will win, but we don't know which one, so it's... Also, another way that I also heard some people actually solve the problem of big schemas is, again, maybe in my mind not really the best approach, but again, it's approach, that you actually just expose different graphical schemas on different endpoints. And basically that way you just like decouple the things. Again, you lose a lot of power of a GraphQL in that way, unfortunately, because then you can go like from one basically schema to another, connections, things like that. But again, it is a way to solving a big schemas. Okay, so what happens also? How actually like we can see what's happening inside about visibility of internals. That's again for me was like one thing that I was really interested, because again, okay, I understand, in a simple use case, I have a schema, I have a code, it's like one-to-one, but again, like how can I have no clue what user is going to call, because user can send whatever kind of request they want. So like how can I actually see what actually my users are calling, how my system is performing, where should I maybe do some optimizations? Again, like what's the user, how do users do stuff? So one thing, very easily, of course, we can just do the logging. And the good thing about that one is there's already like, in the GraphQL, everything is prepared for you. So you just add a line like this, and it's going to start logging all kinds of crazy stuff. Also, there is instrumentation. And again, if you're experienced with the REST or like with the servlets, instrumentation is very similar to the filters, basically what we have like with the servlets and the REST. So basically you have put some codes which are actually going to execute before and after request, and you can do like really crazy stuff there. So you can just do all like kind of metrics, basically look, okay, like what's the time response things. You can completely change the request itself, so you can really go nuts. Not even that, but for example, there's even also like, so this is like a good reference point that you can actually see examples how actually you can write instrumentations. And also Apollo team created their own tracing, where actually you get like the whole tracing of everything, things that happen inside, all kind of stuff. One thing that I'm not really sure is that would I like to actually put this Apollo tracing in production, because the way that it's done is that it sends all metrics and everything as a part of a payload. And I'm not really sure that I want to expose this to my users. In dev, yes, why not? Like in test, maybe. In acceptance, probably not, because it's going to interfere with performance. But in production, I doubt. So in summary, basically we talked about GraphQL. So hopefully now you know what GraphQL is. We talked about how GraphQL SDL, schema definition language, is very powerful. I showed you a lot of demonstrations, so I hope that you got a feeling of all the things that we can do with it. Also, we talked about GraphQL query language with all the possibilities that what actually we can do. So as you can see, like we can like do the filtering, changing of the names, basically doing the conditionals, like do all kind of crazy stuff. You can include, but you can also skip the stuff if you want. And all right, thank you. This all the resources basically used throughout the talk. So basically, this, if you need one slide, this is basically the slide that you get everything. And with that, any questions? Oh yeah, and also don't forget to vote. Yeah.
What about exception runtime errors? How GraphQL handle them?
So by default, so the question is with the runtime exceptions and things like that, what happens? So by default, what's going to actually happen is if there is any, so this is like default behavior. If there's any kind of exception error, it's going to kill all, basically your query request are going to send back error. So that's by default. However, you can actually change that if you want and basically say, okay, like, you know what? If this exception happens, then basically just continue, but also add this error. Because in a payload itself, where's the payload? So let's just, so there is data, right? But if we just add here something which doesn't exist, run it. So basically, you always have data and error. So you can also send, basically, and it's up to you. Do you want to like to kill it and just say, okay, here's the error? Or you can say, okay, like, okay, this is an error, but again, this thing here can still continue working. So basically, send this error to the front end to know, okay, this part crashed, and basically this is like the response that was still valid. So it's basically up to you. Does that answer your question? Yep.
What about if your data structure is a composite type, like order structure? How you can define in the query to go deeper, so not define every level of the query, but say every order recursive or something like that?
Okay, so I'm not really 100% sure that I follow your question. So if I answer your question, is the question is, okay, like in this case we have simple types, but what happens if we have like very like complex type, right?
Yeah, it's
Composition.
So type can basically be recursive. So
Okay, so basically if we go, okay, if I understand you correctly, so let me just find the editor, so just I can write so we can 100% sure. So for example, let's say here we have a speaker and the speaker has a speaker, right? Again, so, ay, caramba. Speaker, okay, so again, in this case, what you would need to do is just come here, basically go to the speaker resolver, and just add public speaker, because we are, what is it, speaker or, yeah, array of speakers. So basically I'm putting that array of speakers, so it says list speaker, whatever, and you just do the logic yourself. So it's there again. There will be no magic actually to save you from recursion and everything.
on the client side, how I say that go and fetch every child? I believe the question is like, is there any star operator, right?
So again, you can again, one thing that also people sometimes think about the GraphQL is it's like a SQL query. Well, it's not really, because you don't have a grouping, you don't have having. And again, there is no really star, but if you just, again, you're going to say, you have like element, and that element has exactly recursion back to itself. You have to specify that self, basically that recursion that you wanted back, that line, in a query itself. So there is no like star or anything. You have, if there's a speaker, the speaker contains a speaker, then you can say, I want from a speaker, and then a speaker, and a speaker, and a speaker. So you have, basically client have to tell that. So there is no magical way that they go around it, if I understand correctly your question. Okay, yep.
Where is the best place to put authorization? So I would like to input fields which are returned. For example, in a talk, I want one user not see the speaker, and so he could only see some fields, some of them will be hidden for him.
Okay, so if I understand your question correctly, it's about authorization, basically, and where it's the best place to put it. But again, like, is your use case, okay, you don't want to expose the speaker completely, or you don't want to expose certain fields of a speaker? So speaker, you don't want to expose it completely. Well, again, like I said, so it becomes a little bit tricky. So in my case, basically because I can expose speaker in this place, all speakers, and I can also expose it through the talk speakers. Basically, in these two resolvers, basically I will have to like do authentication. Okay, fetch the environment, basically check, okay, like is the environment good? Okay, extra from data fetching environment, get the context, check the user and say, okay, like do you have like access to see this field or not? If you don't want to even expose that this field exists, then you really need to go deep into the GraphQL Java implementation that you're using, and I really don't know how to. Basically, I would have to like look at the code, so I can't like go this. So, because that's like two things. So, do we basically protect them to use it? That's easy. Basically, again, there's like hooks in every single implementation. Just use this, and basically it's basically problem solved. However, if you really want to protect who actually sees that field, then you really need to take implementation and see how easy it is to basically extend that part. Again, you can do instrumentation. Probably you can also do instrumentation in that case, because again, instrumentation is going to basically cut every request before. So basically, you can do it, but again, it's still you would have to basically then with instrumentation catch the initial request for the whole schema and change that schema. So that might be, for example, one way. But again, I'm not sure if there's would be an easier way to actually solve it. So protection, basically, that they can use it. It's usually relatively easy. Protection to see it, it's much more tricky. Does that answer your question? Okay, cool. Thanks. Yeah. I'm not sure, 100% sure to follow you completely. So you said, if I understood you correctly, what you said is, okay, we have a queries, right? And we have one-to-one mapping to the Java code. So if your case, if we would want to have complex query, I want, for example, not all talks, but talks that, let's say, start with the letter T and have scored is bigger than that, then basically what we would need to do is, if I go back to here, basically then here, all talks, and we will have to basically pass the parameters. So for example, let's say first letter, string, and then let's say score, int, and then basically I would need to pass these parameters into the Java code. So basically I would just do, where is the query? All talks, right? Basically I would pass it basically here. First letter, okay. And then integer score. And basically here then in Java code I will have to basically use them to actually do the filtering and all this other kind of stuff.
Yes, so in that case, what you're doing there is that custom queries that you're actually writing the jobs, there's a full query. I mean, if you were doing a SQL, you'd write any form of query that you can join from anywhere.
Yeah, so I think I answered your question. So basically, you shouldn't think of a GraphQL query as a special query or anything. It allows you basically to say, okay, what types you have, and for every type, what fields they have. And that's it. And basically, what's the connection between them. And again, for every single field, you can actually send the additional parameters. And then basically, that's going to go directly to Java, basically, in this case, Java code. But then it's it can go to the database, it can go to other server. It's basically just going to call whatever you said. So for example, in my case, I'm using just the database because it's the easiest thing for demo. But in real life, I can actually say, okay, for talks, actually for this specific field from a talk, I have to basically go to some other system. Actually, we had, for example, in one of my basically day jobs, so to say, previously, where we actually, in a REST, we say, okay, if user actually requests this field, it's going to be very heavy, so we have to really protect it, do a lot of caching. But if we just expose it over the GraphQL, then anybody can just hit it at any time. And there was concern. I said, yeah, but that's the concern that you still have. So, does that answer your question or not really?
Not really, because what I'm wondering is if you then change all talks, again, you're actually writing a very specific query in Java to match the anticipated query in GraphQL. You wouldn't want to do that. Normally, you would want to support any form of query.
But so again, it's like when you say you want to support the whole query, again, really, it supports a lot of queries, but again, it supports the queries that are actually thought by GraphQL, so it's a specification. So sending the additional parameters, it's just from the GraphQL point of view, it's just sending additional parameters, nothing else. So it's not, from the GraphQL point of view, that's not query specific. It's just, okay, for this, basically, here I'm going to send parameters, and then something's going to happen in the backend. But again, from the GraphQL point of view, it's just, okay, I just send the parameters, and something will happen, and I will get response. Does that answer your question, or maybe we can just take it offline, because maybe it's easier. Any other questions? Yep.
Are there any client implementations in Java for this?
Sorry, can you repeat?
Are there any client
Yes. So basically, no. So basically, for the clients, there is Apollo. Basically, they have they call it Android GraphQL client, but it's actually pure Java. So if you want to have a client side basically in the Java, that's the one that actually I would look at. Probably there is some other also the clients written for GraphQL. Again, I didn't For my use case, I was mostly in the backend, so that's why I was concentrating basically on that side. On the clients, I didn't really care that much. But I know that basically there is Android, basically they call it Android GraphQL client for Apollo, which you can use also like in Android application, you can use also like in Java code. There's probably some others also that I might not be aware. Does that answer the question?
And then if the format of the query must be in
Yeah, so
or we can choose between JSON, Dynamics, XML, something else.
no. When you basically so that part is basically standard. So the payload that actually this GraphQL sends as a client to the server is according to specification. So basically there is no like choosing there. And any kind of client that actually you select is going to send the queries in exactly the same format. So from that side, there is no choosing. Okay, according to specification, if you're a client, this is the payload that you need to basically send. If you're a server, this is the payload that you need to basically expect and then basically work accordingly. So that's the beauty of the GraphQL, that any client and any server are going to work one-to-one. They're going to work without any problems. The only thing that so far I saw that's its problem is, like I said, where is the thing? Where basically we added like add auth. So basically this, but they actually like one of the implementations basically look okay like we have a problems with authorization and authentication, so we are going to create a custom directive which is going to be called like this, and then for example this is going to be role like manager, let's say. But then this works only with them. So that's why I said I don't like it, because again, like if somebody else comes with some other client, it's going to break. So that's why I personally don't like this approach, and I like to just keep like pure GraphQL, because then whatever client and server you have, like it will be working perfectly. Any other questions? Yeah.
Security over this?
You can. No, nobody's actually protected. There is no reason why you actually can't do it. I didn't do it, so I'm not sure like how easy it's going to turn out. So the question is like, will it work out of the box? The answer is I have no clue. I never tried. So when if you try, let me know. Yeah. Any other questions? Yeah.
Is there support for inheritance on Java side and Schema side? Let's say in Java, we've got the talk subtypes like deep dive and conference, and we know that talk have the stickers. Do I have to make the resolvers of these stickers for every type separate, or just one for the talks now?
So the answer is okay. Like if we have like basically talk and subtalk and basically that like instance in Java, do we have to create resolvers for all of those kind of types, or we can just use one, right? So the answer basically depends on what you want to expose through the query, through the schema. So if you want to expose all those different types, then basically you will need to create resolvers for all those different types. But again, you can use like interfaces and things like that. So basically say, okay, like the subtalk basically implements talk, things like that. So you can play with that. To be honest with you, I didn't try to interface. So I didn't try that, so I will have to check. But also, I think that maybe in that case, also would be maybe would be more useful to actually go with the code first approach than the schemas. Because one thing that at least I was very often asked is, okay, like if we go schema first approach, can we auto-generate all the code and purges and all those kind of things? And the answer is no, because basically GraphQL, they have no clue if that object exists as a purge, or is it like a database, or is it like third-party call, or is it like call over the message, or whatever. So that's the kind of limitation. If you go code first approach, then there is basically annotations that from which you can then generate the schema itself. But again, you need to have then basically classes to put the notation on. But in your case, if you really want to, again, it comes back what you want to expose. You want to expose the type in all subclasses, or basically just one?
Let's say like in this type, I want to have the stickers for talk, for deep dive, and for consumers. We don't put stickers field in the class, in our entity. We just do this by the resolver.
I'm not sure if I'm following, because so you say you don't put it in a type, you put it only in a resolver.
Yeah.
But if you don't put it in basically.
Maybe I don't understand it correctly, but
just a second. So we're talking here like we have a talk. So you don't want to put this one. Okay, but how would you then get the speakers from a talk? Is there any way or?
No, just like we have right now. Yes, we have the talk resolver under
Okay.
and we are fetching there, yes, the speakers, yes. And let's say that I want to have the subtypes of the talk, like deep dive and
Okay, so basically you would say, if I understand you correctly, so basically you have a talk, but you don't have a speakers. But then you have a type subtalk, which basically has the speakers, right? And basically this one's, okay, I don't know, to be honest with you, like, I will have to basically try and play with this. So I can't say, okay, this will be definitely working or not. So for this, I would really have to like play with it, because again, what I would at least try is remove this as a type and put this as the interface. And then basically have this one here basically then implements the talk. But then again, okay, then I have to copy. I don't know. I would really have to like go through the code basically and try. I didn't encounter this problem, so I don't know really. Like, I would just lying to you. Any other questions? Yep. Sorry, the default values? As far as I know, no. But I might be wrong. It was like a long time ago that I actually checked. So I'll basically have to check the like, specification, to be honest with you. I don't remember. I would just be lying to you. Yeah. Yeah. Okay, so if you want to, on the input fields, you would like to validate that there are like some restrictions, things like that. By default, it's no. However, you can do that through the instrumentation. So basically, through the instrumentation, you can just, like I said, like you can change absolutely everything. You get the whole, basically intercept every request, and then basically check, okay, this is the request, this is input, and then you can say, okay, like this is the name like valid name, like these are like only like letters, and is there like, or if somebody like sends some, let's say like bank account, then it has to be like this money, basically there could be like I think like 2 letters, then like 2 numbers, then like there has to be like some format, right? So you can do that in instrumentation, but you have to like write it yourself. So it's not super difficult, but it's not out of the box. Does that answer your question? Any other questions? No? Okay, then thank you very much.